Hey, so I thought I'd create another video about space. Thought I'd get more of a theme going and just, keep the ball rolling. And so, for a while I've wanted to talk about the size, the vastness of the universe, both in terms of time, but also in terms of, sheer scale, yards, meters, that sort of thing. Um, And sort of a question that I asked a coworker of mine a while back was, so you see how huge we are compared to an atom? You know, something so small that 7 septillion of them fit inside of a glass of water. And so imagine, it's like the universe is enormous compared to us from our vantage point. Imagine how enormous the universe must be if you were looking at it from the vantage point of an atom. Considering how small they are compared to us, just picture that. And that was sort of part of me trying to sort of work through this whole idea of just the vastness of space, which I've touched on in other videos, but it's just like the comprehensibility or the incomprehensibility of the size of the universe, and that's just the observable universe. If there's more universe beyond which we can observe, then it could potentially either be infinite or so insanely enormous that for us it's practically infinite. You know, I don't know if maybe that phraseology might not make, actual sense to a scientist, but I'm thinking of a universe that is so, like, insanely huge that even for a scientist, the number of light years may be so ridiculous that it would be effectively, for all intensive purposes, a just incomprehensibly huge universe that to anyone trying to traverse it would feel just infinite. Even with the most high-tech forms of travel you could possibly think of or dream of. But even without that, even without going to an infinite universe, an incomprehensibly large universe outside of the observable universe is still friggin' enormous. I mean, even for us to get to our closest star, Proxima Centauri, would still take us, 4 years, I think, if you're traveling at the speed of light? But that's only if you're traveling at the speed of light, otherwise it would take thousands upon thousands of years. Like, that's the sort of distance we're talking about when you start getting into distances between stars, even. And then imagine distances between entire galaxies, or clusters of galaxies, or just the size of an entire cluster of galaxies, or like the Laniakea supercluster that we exist within, but just the enormous sizes of these things. And the fact that the universe is mostly empty space, the way an atom is, which is, I always find it interesting when you can find parallels between an atom and a large-scale feature of the universe, like the way that black holes, because of their sort of lack of features, their ability to essentially consume matter and destroy information, or make information sort of impossible for us to retrieve in a way that is useful. And so because of this and their really simplified states, spin, charge, mass, they essentially sort of mirror subatomic particles, but I'm kind of getting on topic with that one. But to sort of go back to the sort of comparison of the atom and the universe being mostly empty space, it's a lot of empty space. It scales so huge that it takes us an uncomfortably long time to get anywhere, because there's so much empty space. And to go back to my little analogy about, what is the size of the universe from the vantage point of an atom or subatomic particle, the universe, we're like, to sort of go back to a quote by Carl Sagan when he was referring to the Earth. I mean, if the Earth is a mote of dust suspended in a sunbeam, then we are like subatomic particles. If the Earth is like a mote of dust suspended in a beam of sunlight, then we are like atoms or subatomic particles on that mote of dust in that beam of sunlight. We are tiny. We're so inconceivably tiny compared to the vastness of the universe. I mean, we're like ants on top of the Earth, or maybe even germs, if you really want to kind of take the size comparison to what most fits. Like, once you start thinking about how minuscule we are, sure, there's like 7 billion of us, so we can have an impact, as a collective. But as individuals, as any one individual human like me, I'm tiny. I mean, I'm short, compared to other humans, but compared to everything else that exists in this vast universe, I'm insignificantly small. I mean, you think about how small a room can be, or how claustrophobic a space can be, and then you sort of think of the irony of that space, or you being in that space, that the irony of that existing, or you existing within that space, while all of that, you and the claustrophobic space included, both exist within a universe that is so incomprehensibly large that you could float forever and never hit anything. Possibly. It is the sort of the enormity of the universe that is the topic of this video, and that has been sort of racking my brain for a while. I mean, for a long time, but trying to prepare myself to make this video, I've been I've been chewing on it for a while, and it's really insane when you start to think about it. And the sheer scale of the universe, just in itself, it's a remarkable thing. It is it's not something to scoff at, to the point where interstellar travel is itself a monumental feat to overcome, let alone intergalactic or, traveling across the universe. All of those things are monumental tasks to overcome. Just because of the sheer distances involved, because of the sheer size involved when you're talking about the universe as a whole, and the size of the universe just generally. It's really crazy. I remember I was watching a video, I think it was on Numberphile, talking about how if you had a universe that was a Googleplex light years large, or even a Googleplex light year, I can't remember which one it was, but if it was sufficiently large, you would eventually have a situation where if you went far enough, because of the enormous distances involved and just the sheer, the way chance works in a universe that large, essentially you would eventually run into a copy of yourself, or something that looks a lot like yourself. You would start to see repeats of physical objects that you may have seen before. And that's essentially because you have so much space to work with, and potentially so much time to work with, but I'm going to get into the vastness of time in another video. This one's just about space. You have so much space to work with that seemingly impossible or improbable states of matter, or sort of combinations of matter, become sort of inevitable, because the numbers are just so insanely large. And it's really insane. The more you think about it, the more you sort of realize how We're tiny. We're practically insignificant. I mean, we play a huge, like, I don't want to say that and brush over it too much, because we are significant in terms of our own sort of Earth biome, but in terms of the universe at large, we might as well not exist. That's how tiny we are. That's how small an effect we have on everything else. And I mean everything. Everything. So, it's one of those sort of very humbling facts to think about. Like when you look up at the night sky and you see, like, you know, Orion, which I can usually see from here in New York. You think about that and you realize just how, I mean, part of why for me seeing the arc of the galaxy would be so moving would be in part because you're in seeing the galaxy, you sort of have to internalize the vast size of it. I mean, you're looking up at a collection of millions of stars, each of which are light years apart from each other, and you're looking up at them. So the structure that you're looking at is many light years across. And so, and, I mean, our Earth with our sun is many light years away from all of those stars. And even further away from the galactic center, which houses, you know, Sagittarius A, which is the center of the galaxy, the heart of the galaxy. And it is insanely far away, even though it is in the same galaxy as we are. And part of seeing the arc of the galaxy, part of what makes it so moving is not only sort of the beauty of the stars and the interstellar dust that you see, the interstellar medium, but also just the sheer distances and size involved in the structure that you're looking at. Or if you happen to be able to see further than that, if you have a really good and clear sky and you can see not only the Milky Way, but also its satellite galaxies, and maybe even Andromeda if you have a good telescope or can see well enough, because it does essentially appear as a small smudge, essentially. It's that small in the night sky. And Andromeda's even further away, even more incomprehensibly large and distant from us. And yet, because of the way light works and the power of stars, you know, the sheer energy that they're able to put out and the distances which their light can travel to reach us, we can see insanely distant objects like the Andromeda Galaxy from here. I mean, something that I always remark on when I'm looking up at a star with anyone else is just thinking about how far that starlight had to travel to get to your eyes. That in itself is an insane thing to think about. Just the fact that those photons are taking thousands of years potentially to reach your eyes. And, you know, that journey is over distances of comparatively empty space just to hit your eye, just so that we can see them here on this tiny planet. And then, like everything that you can potentially house even in our universe, so many possibilities, because there's so many possible combinations in such a vast universe. So many things can happen. Back to the entire idea of when you have a universe or a space that is sufficiently large enough that can house all types of combinations of matter, even improbable circumstances in which that matter can exist become essentially inevitable. To sort of repeat what I said earlier, but in the context of the universe and our own existence. But not only our existence, but maybe microbial life on another planet, possibly intelligent life on another planet, like similar to us, but just so far away, as I said in a previous video on aliens, that we are essentially on these sort of desert islands of life that can never interact with each other because they're so far away from each other, sadly. But yeah, and just the insane worlds, this insane worlds that can exist, the number and variation of them that can exist in such an enormous space, the huge structures such as like a massive quasar jets that can stretch for like thousands of light years, all stemming from essentially a single object that can itself maybe be at most, I don't know, probably itself like a light year or more across, but it's giving off this sort of energy beam or sort of particle jet that can reach for several times the size of the object itself and can essentially just float into space forever. It has a lot of room to work with. We are so tiny. We are so tiny, to the point where I'm not even sure that I'm doing enough to sort of state that here. And I think this will be a good way to lead into the next video that I wanted to make, which is sort of the flip side of this one, which is going to be about time, just the vastness of time. But I'm going to mention space quite a bit because they are essentially linked. They are, for Einstein's purposes in general relativity, and for scientists that continue in that same vein of thinking, they are essentially two sides of the same coin, and so are inexorably linked to each other. But I want to talk about it as essentially its own thing in the next video because different sort of considerations come into play when you think about just time in and of itself and the insane sort of scales of time, even with just the universe as it is currently, let alone the distant future when you start talking about like the evaporation of black holes and the death of red dwarf stars. But I don't want to get too much into it now because then it just kind of spoils the whole idea of the next video. So I'm gonna end it here. I'm hoping to do more science-related videos. I think what I'm going to do is just sort of try to expand upon any ideas, any science or astrophysics-related ideas that I've done in previous videos. Try to expand on them and sort of, jump into them in ways that maybe I haven't before in other videos that were more philosophically oriented, if you understand what I mean. But yeah, that's all for this video. I hope everyone's doing okay, and become one.